In this video, I want to have a look at maximum and minimum problems. So there's lots of things in real life that can be approximated by quadratic equations or parabolas. So if we look at our two types of parabolas, if we've got a concave up parabola, then its vertex is a minimum value. So whatever the y-coordinate of that point there is, that's the minimum value that that parabola reaches. If we've got a concave down parabola, then it has a maximum value instead. So the y-coordinate of this vertex, that there is a maximum value. So it's the maximum value that curve reaches. So if we're using parabolas and quadratic equations to represent situations, we can find minimum and maximum values. So let's have a look at an example. So we've got a farmer that wants to fence a rectangular paddock, and he's got 48 metres worth of fencing for 3 sides of that paddock because the 4th side is a river. So what that's going to look like is if we've got our river going along here, we're going to have our paddock coming off it as a rectangle. So the first part of the question says, let the paddock have a width of x metres. So that means this length here, the length of this side is going to be x, and because it's a rectangle, that means this one's going to be x as well. Then it says, show that the length of the paddock is 48 minus 2x. So for now, if we're figuring that out, let's call that the length of that paddock, let's call that y. Then we know that all 3 of those sides have to add up to 48 metres. So x plus y has to equal 48 metres. Now if we simplify that, the x plus x is just 2x. We've got 2x plus y is equal to 48. So to figure out what this length is of our paddock, we're going to get that y on its own, which means we're going to subtract 2x from both sides. So that means that the length of that paddock, we can get rid of that y, and it is 48 minus 2x. Okay, so that's part A. Part B says, find an expression for the area of the paddock. So part B. So because that paddock's a rectangle, to find the area, we're going to go the length times the base, or the width. So in ours, that's going to be our x times this length along here, which we just said is 48 minus 2x. We're going to have x outside of 48 minus 2x, and then we're going to have to expand that out. So we're going to have 48x minus 2x squared. Now, because of that squared terms, that means that this equation is a parabola. And what that means is it's going to have a maximum and a minimum value. So because it's a negative coefficient of that x squared term, it means we're going to have a concave down parabola, which gives us a maximum value. So this equation will have a maximum value. And that comes in handy with part C, because it asks us to find the dimensions of the paddock that will give the maximum area. So we want to find when this equation is a maximum, what value of x gives that equation a maximum. What that means is that we're going to have to find the coordinates of the vertex of our parabola. So one way that we can do that is to draw up a table of values. So parabolas are always symmetric, so we're looking at where that symmetry comes together and where our vertex is going to be. So to start off, we're going to have our x values and our area, and then we're going to just pick some values to start off with. So let's say we've got 48 metres of fencing. Let's say we put 10 metres width, and we can figure out what the area is going to come out to be. So if that paddock was 10 metres wide, to find the area, we're going to go 48 times 10 minus 2 times 10 squared, and that would give us 280. So 280 looks pretty good, but we don't know whether that's a maximum or not. So let's test something else. So let's test if that was 11 metres wide. So again, we sub that 11 into that x in this equation. So we're going to have 48 times 11 minus 2 times 11 squared, and we'd end up with 286. So that means that we're moving in the right direction because our numbers are getting bigger. Let's keep going and see how big they get. So if we have 12 metres, so we're going to substitute that in. So 48 times 12 minus 2 times 12 squared would give us 288. So again, we're still getting bigger. Let's keep going. So 13 metres wide, we'd have 48 times 13 minus 2 times 13 squared, which would give us 286. So that means we've come back down again. So our maximum value, because this 286 here and this one here, because our parabola is symmetrical, if they have the same value, then exactly halfway between them is going to be our maximum. So exactly halfway between 11 and 13 is our 12. So our value of 12, our x value of 12, is going to give us the maximum area. So that means that x equals 12 will give us the maximum area. And let's just find the other dimension. So we know how wide our paddock's going to be. We just need to know how long it's going to be then. So that means our y, which is this here, our length, we found that by going 48 minus 2x, but our x is 12, so 2 times 12. So 48 minus 2 times 12 will give us 24. So the paddock is, its width is 12 meters, and its length is 24 meters. Okay, so that's one example of how we can use parabolas and quadratic equations to solve maximum and minimum problems.